All right, I had some technical difficulties with the recording through my math lab, so I gonna have to just do it this way: make a recording and put it up on YouTube and send you guys the link. So here's what was supposed to be today's review session. Um, the basic idea for today's review session is you got two quizzes this week: quiz 7, quiz 8. So as I always do, I kind of just grabbed a bunch of topics that I thought were, I don't know, things that you might need a little bit of help on, or things that maybe I can shed some extra light on, and made a list, and I'll go through them. Keep in mind you got your midterm next week. So next week's review session, we'll have it be on Wednesday instead of Friday, as we've been doing, Wednesday at 3 o'clock. And if there's anything in particular you would like to have me go over, please let me know. I'd be glad to do it. Otherwise, maybe I'll do the practice midterm or something. I don't know. Figure out a way to fill the time. All right, without further ado, we'll start with some quiz 7 topics. In quiz 7, there's a lot of, starts out kind of doing some geometry stuff. So one thing you might be asked is to determine whether 3 points form a right triangle. I mean, you can kind of get a ballpark idea by graphing these points. It looks like they're all in the first quadrant. I got the point 1, 2. Then I got the point 2, 1, 2, 3, 4, 5. And then I got the point 0, 11, so some point way up here, not drawn to scale. It looks like I kind of come up with some triangle here. And sort of my question is it a right triangle? Are any of these three angles 90 degrees? Looks like this would be the one that might be close to 90 degrees. It looks like a little more than 90 to me, but maybe that's just a result of me being a horrible artist. Maybe it really is 90 degrees. So a way we can figure it out a little bit more succinctly is we can come up with the slope of each of these three lines, right? There's three lines that form a triangle. We can come up with each of those three. Maybe we'll call this A, B, and C, and then I can denote the slope of the line that goes between points A and B, like this. And the way you find the slope of the line between any 2 points is it's the difference in the two y coordinates divided by the difference in the two x coordinates. So in this specific case, if I want to find the slope of the line that connects points A and B, I'd have to take these two y coordinates. Maybe I'll call this x1, y1, and x2, y2. So it's x1, y1, x2, y2, and I guess I'll call this x3, y3. So if I follow my formula, y2 is 5 minus y1 is 2. And that's getting divided by x2 is 2, and x1 is 1. 5 minus 2 is 3. 2 minus 1 is 1. What I get is that the slope of the line between those 2 points is 3. And that in and of itself tells me nothing, but if I calculate the remaining slopes, the slope of the line between B and C, and the slope of the line between A and C, what I can do is I can compare these three slopes, and if any of the lines are perpendicular, then their slopes will be negative reciprocals of each other. What I mean by that is if, what did I just do? This is A, this is B, and this is C. So I just figured out that this line right here has a slope of 3, which looks reasonable. It goes up by 3 every time it goes over by 1. If either of the other two lines are perpendicular to this line, then their slope will be negative 1/3. In order to be perpendicular, maybe M1, I should say that, a line with slope, fine. I'm just going to say M1 and M2. What I mean by this is a line with slope 1 and a line with slope 2 are perpendicular if M1 is the negative of 1 over M2. That might help you if you're a very formulaic person. A more layman's terms way to say that is if I get negative 1/3 for either of these two answers, then the line for which I get that answer is perpendicular to this first line. Maybe I should stop talking and just do it. The slope of the line between B and C, I need the difference in their y coordinates, so maybe I'll do 3 minus 2. I got 11 minus 5, and I'll divide that by 0 minus 2, the difference in their x coordinates. And when I do that, 11 minus 5 is 6, 0 minus 2 is negative 2, and I get negative 3. That's saying is this line right here between B and C has a slope of negative 3. These are not perpendicular. If it were 3 and negative 1/3, they'd be perpendicular. If it were 1/3 and negative 3, they'd be perpendicular. Being the negative of each other does not make it perpendicular. These two lines are not perpendicular. So I'm pretty sure I don't have a right triangle. Just to be certain, let's do this one more time with A and C. The y-coordinate over here is 11. The y-coordinate here is 2. The x-coordinate here is 0. And the x-coordinate here is 1. 11 minus 2 is 9. 0 minus 1 is negative 1. So I get negative 9. Because none of these are negative reciprocals. You don't need to know that word. Might not have even spelled it right, I'm not sure. Not a right triangle. So, what am I getting at? Triangle. If you see something like this on a quiz, calculate the slopes. And if any of these numbers are the negative of another number flipped upside down, it's another way of saying reciprocal, then you have a right triangle. If not, you don't. In this case, I don't. Moving on. Okay, in this second problem, we're asked to determine whether these 4 points, I kind of changed the numbers a little bit, got rid of this guy, form a parallelogram. What you need to know about a parallelogram is it's a 4-sided figure for which it has 2 sets of parallel lines. So I tried to graph each of these points, and if you graph them kind of a little bit more carefully than I graphed them, you might be able to just look at it and tell whether there's 2 sets of parallel lines. Like, is this guy parallel to this guy? Yeah, it might be, hard to tell. What about this guy and this guy? And they don't really look like it in my picture, but maybe it's just a bad picture. Maybe this really is parallel to this. So we better get a more algebraic way rather than a geometric way of figuring out if this is a parallelogram. And the way we'll do it is just like we did up top. We'll first give these guys all a name, A, B, C, D. A being this point, B being 2, negative 2, this guy, C being this guy, and D being this guy. And we'll calculate the 4 slopes. And if for lines to be parallel, they have to have the same slope. So if I have 2 different pair that have the same slope, then I know I have a parallelogram. So let's figure it out just like we did above. We'll need MAB, this guy right here. We'll need MBD. We'll need the slope of CD. And we'll need the slope of AC. And the way we'll figure those out is just like we did above. Between A and B, we'll say the y-coordinates. This has a y-coordinate of 1. This has a y-coordinate of negative 2. A has an x-coordinate of 3. And B has an x-coordinate of 2. And if I subtract those, 1 minus negative 2 is 3. 3 over 2 is 1. I get that this line right here has a slope of 3. If CD has a slope of 3, then these two are parallel, and I'm halfway to a parallelogram. So let's figure it out. The slope between CD, well, the difference in the 2 y-coordinates, this y-coordinate is 4, this one is 0. So I get 4 minus 0. The difference in the 2 x-coordinates, this one is negative 3. This one is negative 5. So 4 minus 0 is 4. Negative 3 minus negative 5 is the same as negative 3 plus 5, which is 2. Get a slope of 2. These are not the same, so these are not parallel. Because these are not parallel, I don't have a parallelogram, because to have a parallelogram I have to have 2 sets of parallel sides. We can go on and do the rest of the calculations just to show you how it's done, but I already know the answer. Is it a parallelogram? Nope, sure not. BD, we do the same idea. The difference in the y-coordinates would be, I don't know, maybe let's do this one first. 0 minus negative 2. And the difference in the x-coordinates, I got negative 5 here, and I'm subtracting 2. And so what I get is 2 divided by negative 7. In other words, negative 2/7. And then AC, see the difference in the 2 y-coordinates. So this has a y-coordinate of 1, this has a y-coordinate of 0. So I get 1 minus 0. X coordinates, this has a 3, this has a -5. 3 minus -5. What I get is 1 divided by 8. So I messed something up there. AC. I think I put the wrong numbers in there. Let me redo AC. So AC is this guy and this guy. So the difference in the y coordinates is 4 minus 1. Y and y. And the difference in the x coordinates is -3 minus 3. So I get 3 divided by -6, which is -1/2. It looks like those aren't parallel either. I didn't need these to not be parallel to draw my conclusion, but the answer is no. I don't have two sets of parallel lines. We can take this one step further. Imagine a case where you did have two sets of parallel lines. Maybe these are both 2 and these are both -2/7. Right? If this was 2, this was 2, this was -2/7, this was -2/7. Then when they asked us to form a parallelogram, you say, yes, it does. There's two different sets of parallel lines. However, it would not be a rectangle, because to be a rectangle, not only do you need two sets of parallel lines, but you also need a right angle. And in order to have a right angle, we must have perpendicular lines. And in order to have perpendicular lines, the slope of one of them has to be the negative reciprocal of the slope of the other one. So a case when we would have a rectangle is if this were 2, and this were 2, and this were -1/2, and this were -1/2. Then I'd have two sets of parallel lines because 2 is the same as 2, and -1/2 is the same as -1/2. And furthermore, those lines are perpendicular because the negative reciprocal of 2 is -1/2. But that didn't happen in this case. In this case, the answer is no. Circles. All right, enough with rectangles and triangles. Rectangles and triangles kind of a minor part of this quiz. It doesn't show up a whole lot. I mean, it shows up a little bit. I think circles shows up a little bit more. For circles, you need to know a few things. The first thing is kind of the standard form of a circle. So what I mean by that is typically when we have a straight line, the standard form of it is y equals mx plus b. This is something we'll see later on in this video, I believe. And the m is the slope and the b is the y-intercept. So if I get something like y equals 2x plus 3, I know what that line looks like. I say, well, it's got a y-intercept at 3 and it's got a slope of 2, so I can draw that thing. We don't have lines here, we have circles, but there's something very analogous going on, that it has a standard form. So just like lines fit y equals mx plus b, circles fit y minus k squared plus x minus h squared. Let me write those in the other order. I'm going to say x minus k squared plus y minus h squared is equal to r squared. And what I mean by this is the standard form of a circle, much like y equals mx plus b is the standard form of a line, but it only helps if you understand what m and b are in the case of a line. Similarly down here, it only helps if you understand what the k, the h, and the r represent. This is the standard form of a circle with a center at the point k, h. So note the number that's here is the x coordinate of my circle, and the number that's here is the y coordinate of my circle. And the r, that's the radius of the circle. So what I'm saying is if they tell you the x coordinate of the circle, the y coordinate of the circle, and the radius, we can put this into standard form. Just like if they told you there's a line and it's got slope of 2 and y-intercept of 3, you could write it in standard form. So what we do is we copy our standard form, except instead of writing k right here, I want to write what the x coordinate of the center is. That's given to me as 2 in this problem, so I'm going to write x minus 2 squared. And now I'm going to say y minus, well, whatever h is. H is the y coordinate of the center. That's given to me as -3. So I got y minus -3. And then finally that equals the radius squared. The radius is 4. So I get 4 squared here because I want r squared on this side of the equation. And honestly, this is fine the way it's written, but typically you clean it up a little bit. say, wait a minute, if I'm subtracting -3, doesn't that just mean I'm adding 3? Yes, it does. And 4 squared, isn't that just 16? Yup, sure is. So for standard form, really can leave it in either of these two forms. I'm fine either way. This one's a little bit cleaner, less parentheses, less operations out there to do. This one really emphasizes where the center is and what the radius is. So I don't know, in a sense this messier one's better. I don't care which one you use, either one's fine. Okay, so as long as they tell me the center and the radius, I can come up with the standard form. The question becomes a little bit more difficult, maybe a little bit more interesting, if instead of telling you that information, they ask you for that information. So that's what I'm doing down here. Instead of telling me that the center is at 2, -3, and the radius is 4, it says, what is the center and what is the radius? So it's the same thing except it's switching question and answer. And so you're like, well, if they gave me something like this, I could just look at it and say the center's at 2, -3, and the radius is 4. But they don't give you something like this, they give you something like this. So what do? Well, we got to learn methods to algebraically rewrite this thing so that it fits this form, so I can read this thing and tell what the center and the radius are. It's hard to do. To algebraically rewrite this thing so that it looks like this, it's not easy. It's hard to do that. There's a method for doing it called completing the square. If you remember a couple quizzes ago, one of these review sessions, I said we were solving quadratic equations. I said you could use the quadratic equation or you could solve it by completing the square. You might want to use completing the square because we'll need it later on. This is later on. If you didn't learn it then, you can learn it now. And what you do, what I do, is I first rewrite these things. I kind of write my terms with x's in them by themselves, so x squared minus x. And then I got my terms with y's in them, which was y squared. Looks like plus 4/3 y. So I'm going to be dealing with fractions also. And then I got this number right here. I move that on the other side of the equation. So I add 75/36 to both sides to get here. And I like to space things out a little bit just so I can really see this is one group, this is another group, and then here's the number on the other side of the equation. And so my goal is to figure out a way to change this into something that looks like this. So this up here is a perfect square. Right? X minus 2 squared is a perfect square. This is not a perfect square. It turns out that if I had the number 1/4 right here, then I would have a perfect square. Turns out that what I've written, the line below, is x minus 1/2 squared. If you don't believe me, you can FOIL this thing all out. You can do x minus 1/2 times x minus 1/2, and what you'll see you get is exactly this thing right here. Which is not this, it's not what I have, but this is pretty damn close to this. So if I could change this into this, and then recognize that I have a perfect square here, I can write it like this. And why this third form is so great is this third form is starting to look like my standard form. So what I want to teach you is how to go from here down to here. So the first thing you want to do is we're going to have to add some number to both sides of the equation. In this specific case, that number that I added to both sides of the equation was 1/4. Right, this 1/4. I can't just put it over here unless I add it to the other side also. So the question becomes, how did I know this was 1/4? And then how do I recognize that when I'm looking at this thing right here, I have a perfect square, specifically that this equals this? It all comes down to naming things. So what I'm saying is when we have 1 as the coefficient on x squared, what we're going to call b is the coefficient on x. So in this case, it's -1. Over here, we're going to call b 4/3, the coefficient on the linear term. Right? There's a -1 here, there's a positive 4/3 here. And so what you'll need to know are two things. What b divided by 2 is. So in this case, my number b, -1, divided by 2 would give me -1/2. And then also what b divided by 2 squared is. Well, b divided by 2 squared is -1/2 squared, right? Because b over 2 is -1/2. And -1/2 squared, and negative times a negative is a positive. 1/2 times 1/2 is 1/4. The two pieces of information I'll need are b over 2 and b over 2 squared. And what you'll see, what ends up happening is b over 2 squared is always what I add to both sides of the equation in this first step. So how did I get this plus 1/4? By doing this work first. I saw this 1/4 here, I added it to both sides of the equation. When I'm dealing with my y's, maybe I can do it parallel, do it right next to each other. I'm going to have to add some number to both sides of the equation. I want to choose that number very carefully so I end up with the perfect square. What number do I add? Well, if you're really good at these, you might be able to just see what it is to form a perfect square. Most people can't do that, so instead you go at it this way. You say, well, what I want is b over 2. b is 4/3, so b over 2 is 4/6, which is the same as 2/3. If you have trouble seeing why b over 2 is 4/6, instead of thinking about it as dividing this by 2, think about it as multiplying this by 1/2. 4/3 times 1/2 is 4/6, which is 2/6. Which is 2/3. b over 2 is 2/3. The other thing I need is b over 2 squared. Well, that's just 2/3 squared. 2/3 squared is 2/3 times 2/3, which is 4/9. What this means is that the number I'm going to add to both sides of the equation in this first step is 4/9. It's rare that you can say always in math. It's always b over 2 squared. Add 1/4 to both sides, add 4/9 to both sides. Did that in this step. And by doing that, what you have created are two perfect squares. This one is x minus 1/2 squared. How did I know it was x minus 1/2 squared? Because it's always x plus b over 2 squared. X plus negative 1/2 is x minus 1/2, and then I just got to square that. So what do I get over here? I'd have y plus b over 2, which is this 2/3, squared. If you're not sure if you did this right, if you're not sure this should be y plus 2/3 squared, FOIL this all out. Do y plus 2/3 times y plus 2/3. What you'll see you get is this step above. What I now have on the left-hand side of the equation looks a lot like this. That's good news. Right, it's close to my standard form. All I got to do is figure out what number is on the right-hand side of the equation, because that number is r squared. Well, what is this number? Let's see. 75/36 plus 1/4 is the same as 9/36. I multiply the top and the bottom by 9. 4/9 is the same as 16/36. I multiply the top and the bottom by 4 to get this common denominator of 36. And if you add those all together, 75 plus 9 plus 16 is 100. So I get 100 over 36. So what I'm saying is that the standard form of this circle is x minus 1/2 squared plus y plus 2/3 squared is equal to 136. This is the standard form of the circle. Now that we know the standard form of the circle, we can go up and answer the question. The question said, what's the center and what's the radius? Well, the center are the things that are getting subtracted from the x and the y. That's the x and y coordinates of the center. So in this case, I'm subtracting 1/2 from the x. So my center is at positive 1/2. The x coordinate of the center is 1/2, x minus 1/2. The y coordinate of the center is a little bit tricky. You might think it's 2/3, but it's not. It's negative 2/3. And the reason why is the y coordinate of my center, h, is the thing that shows up here as y minus h. So if I wanted to view this as y minus something, I'd have to think about it as it's y minus negative 2/3. Makes this negative 2/3. Radius, common mistake to call it 136. 136 is not the radius. 136 is the square of the radius. The radius is equal to the thing that you square to get 100 over 36. In other words, the square root of 100 over 36. Turns out that's 10/6, or if you want to reduce it, it's 5/3. What I get from my answer is that this is a circle. It's got a radius of 5/3, and it's got a center at 1/2, negative 2/3. Stuff's pretty hard. I only wanted to do one of these type of problems, just for time's sake. So I chose a really hard one with a lot of fractions and stuff. If this gives you trouble, maybe try some with easier numbers, look through the homework and get a grasp of it, and then come back to this one, or use this as a guide for figuring out easier numbers. Okay, third topic on, what are we talking about, quiz 6 here? Quiz 7, I mean. It's just general graphing stuff. Honestly, this is a little bit easier than the stuff we did above, but I figured I should mention it in passing. The first thing are quadrants. When you're graphing points on our coordinate plane, on our Cartesian coordinates, you might end up with a number up here, over here, over here, or over here. You might end up with a number that's above the x-axis and to the right of the y-axis. If you do, you're in what's called quadrant 1. The rest of the quadrants we fill out by moving, what's that, counterclockwise, I guess. So what I'm saying is if we had a point like 1, 2, 3, 4, 2, this point right here, 4, 2, and you are asked what quadrant is the point 4, 2 in, your answer would be quadrant 1. And the reason why is you'd graph it and you'd be up here and you'd say, oh, all the things up here are in quadrant 1. Another way to look at it is if both the x and y coordinates are positive, you're in quadrant 1. If the x coordinate is negative, negative 3, but the y coordinate is positive, so a point like this, negative 3, 1. X negative, y positive, we're in quadrant 2. If the x is negative, negative 4 maybe, and the y is also negative, so maybe I'm here, I'm at negative 4, negative 3, then I'm down in quadrant 3. And finally, if the x is positive, but the y is negative, so like this point right here that's at 2, negative 4, then I'm in quadrant 4. You can either memorize the sign thing, or I think it's easier to memorize the picture and then just plot the point. Be like, oh, that's in 2, that's in 3. Do whatever the hell you want. It's a quick refresher on quadrants. X and y intercepts. So there are points that are not in any of these 4 quadrants. Specifically, they're points that end up on your axes. If we end up on this horizontal axis called the x-axis, then we're not in any of these quadrants. That gets a special name. It's called the x-intercept. So x-axis, if you're on the x-axis, that point is the x-intercept. So you can get a circle like, what was our answer to 2b? Like this mess, x minus 1/2 squared plus y plus 4/3. Was it 4/3 or 2/3? 2/3. Squared equals 100 over 36, which if you wanted you could reduce that. You could, 4 goes into both of these, so maybe instead of 136 I'll call it 25/9, just to keep the numbers a little bit smaller. Anyways, x and y intercepts, this circle right here, I could graph it because its center has an x coordinate at 1/2, so if 1's right here, its x coordinate is here, and a y coordinate of negative 2/3, so we're talking about somewhere in here. Here's the center of this circle. And the radius of this circle, 25/9, well, let's see, that's a little bit more than 2, right? 18/9 would be 2. So a little bit more than 2. 2 is way out here, is this distance. So if I go about that distance above, kind of end up, loosely speaking, very loosely speaking, with the circle that looks more or less like this. Close enough. Here's the center, there's the circle. When it asks for the x-intercept of this circle, what it's asking you for is it says this circle is going to cross our x-axis actually in 2 spots. Here's one here, and there's another one, off the page out here. Those are the 2 spots where it crosses the x-axis. The question is asking what are those 2 points? And the way you can figure it out is those 2 points have a very special property to them. They both have a height of 0. Right? If you're going to end up on the x-axis, your height has to be 0. The height is the y-coordinate. So the way we can find this point and the one over on the other side is by saying, well, this point has a height, a y of 0. So make y equal 0. Let's figure out the x-intercepts first. Set y equal to 0, and then solve for x. A point of caution, you're looking for the x-intercepts, you set y equal to 0. That screws with some people. X minus 1/2 squared plus y, not y, 0, plus 2/3 squared equals 25/9. This is an equation with one variable in it, x, so I can solve it. Let's see, x minus 1/2 squared plus 4/9 is 25/9. 2/3 squared is 4/9. So subtract 4/9 from both sides of the equation. X minus 1/2 squared is 21/9. So to get the x by itself, I have to get rid of this square root sign. Take the square root of both sides. The square root of 21/9 we could write as the square root of 21 over the square root of 9. But the square root of 9 is just 3. You get here, you're doing everything great, but you made one little mistake. Anytime you take the square root of both sides of an equation, you got to put in a plus or minus. And why that's important is there's two different x-intercepts, right? There's one here and there's one over here. I need to get two different answers. If I don't put in that plus or minus, I don't get two different answers. Finally, add 1/2 to both sides. 1/2 plus or minus the square root of 21/3. Whatever those numbers are equal to. 1/2 plus this number is this point way out here to the right, and 1/2 minus this number is this point right here. Those are my two x-intercepts. Do that same logic to figure out the y-intercepts. I don't know where I'm going to do it, a little bit low on room. Y-intercepts, I set x equal to 0. Because the y-intercepts, this point and this point, the special property that they share is their x-coordinate, the left and right, is both 0. So we set x equal to 0, and we solve. I got 0 minus 1/2 squared plus, so I'm taking my original circle equation here, y plus 2/3 squared equals 25/9. And so to solve this, negative 1/2 squared is 1/4. 1/4 plus y plus 2/3 squared is 25/9. Maybe I jump up here. To get the y all by itself, I'll also have to subtract 1/4 from both sides of the equation. Y plus 2/3 squared equals 25/9 minus 1/4. Yuck. 25/9 minus 1/4 is the same as 136 minus 9/36. I need to get a common denominator if I'm going to subtract these. 100 minus 9 is 91, so I get 91/36. I'm going to erase that because it looks really ugly. You subtract fractions, you get 91/36, which is what I'll write here. Okay, we're close to done. I have to get this y all by itself. To get this y all by itself, I'll take the square root of both sides of the equation. Much like before, you got to remember that when you take the square root of both sides of an equation, you put in the plus or minus. Plus or minus the square root of 91/36 is the square root of 91 divided by the square root of 36. But the square root of 36 is just 6. So what I get is y equals negative 2/3 after I subtract 2/3 from both sides of the equation, plus or minus 91/6. Those are my two y-intercepts, those are my two x-intercepts. You can be asked questions about finding x and y-intercepts both if we have lines and if we have circles. It's a little bit more cumbersome algebraically if they're circles than it is if they're lines. But the nice thing is either way the method is the same. You want the x-intercept, set y equal to 0 when you're in standard form and solve for x. You want the y-intercept, set x equal to 0 from your standard form and solve for y. That's what we did here and here. Alright, midpoint and distance, the last two topics on this quiz, or the last two that I'm going to go over anyways. Midpoint's not that interesting. It's a formula. Two ways to get at midpoint. One way is by memorizing this mess that I'm about to write. This is probably not the best way to do it. So you go through and you say I have 2 points. Let's call this one x1 and this y1 and this x2 and y2. Doesn't matter if you call these guys x1, y1 or these guys x1, y1. And then plug it into this formula. So don't even think about what this means. x1 plus x2 is 1 plus negative 4. That's a negative 4, I promise. Divided by 2. And then the y's, I got 3 plus 11 divided by 2. And a comma in between them because the midpoint has to be a coordinate pair. It has to be an x and a y. And if I simplify that a little bit, 1 plus negative 4 is negative 3. So I get negative 3 halves. And then 3 plus 11 is 14. 14 halves is just 7. This is my answer. Midpoint, if you want to just memorize that, that's fine. I don't like telling people to memorize stuff, so I want to tell you where this comes from, and it might make this easier. So in order to be the midpoint between 2 points, let me graph these, even though I don't know that you really need a graph of them. 1, 3 is this guy up here, and -4, 11, somewhere up here. The midpoint between these 2 points, roughly in here, has 2 special properties. Its x-coordinate, the x-coordinate of this point, is exactly halfway between the x-coordinates of these 2 points. And the y-coordinate of this point is exactly halfway between the y-coordinates of these 2 points. So really, if you want to find the midpoint, all you got to do is find the average of the 2 x-coordinates and the average of the 2 y-coordinates. If you've ever seen anything on average, the way you find the average is you add them up and you divide by 2. Halfway in between 1 and -4 is this point -3/2. It's just finding the average of the x's, the average of the y's. There you go, there's midpoint. Distance, same basic idea. I could just give you a formula. In fact, I will give you a formula. And then I'll try to draw you a picture to explain where it comes from. This is the distance formula. Sure, go ahead and memorize it if you want. The problem with it is it's easy to make a little mistake, like change a minus sign into a plus sign, to confuse it with this formula up here, to have things close but not quite right, and then you're getting the wrong answer. But if you have this formula, you have the answer to any distance question. If it asks you the distance between these 2 points, arbitrarily label them x1 and y1, x2 and y2, and then say, well, the distance is just the square root of the sum of 2 things. y2 minus y1 is 7 minus 3 squared. And then x2 minus x1 is -1 minus 2 squared. So I got a formula, I could figure it out. See, 7 minus 3 is 4. -1 minus 2 is -3. 4 squared is 16. -3 squared is +9. 16 plus 9 is 25. What I'm getting is that the distance between these 2 points is exactly 5. As long as you can memorize this formula and do the arithmetic in here, you can get the right answer. I don't like memorizing the formula, so here's another way you can do it. A little bit more intuitive, I would say. Draw a graph of the 2 points. It doesn't have to be precise. 2, 1, 2, 3, 1, 2, 3. Here's 1 point up here. The other point, x is -1, y is 7. 1, 2, 3, 4. I have a bad habit of having graphs running into graphs. 5, 6, 7. This point right here. What the question is asking me is how far apart are these 2 guys? What's the length of this red line right here? Figuring out the length of diagonal lines is hard to do. It's easy to figure out the length of horizontal lines or vertical lines. So if, for example, I didn't ask you to find the length of that line, if I instead asked you to find the length of this line, you could do it. And then if I asked you to find the length of this line, you could do that too. So what I'm saying is if you wanted the length of this line, you'd be like, well, the height here, the y-coordinate is 7, and the y-coordinate down here is 3. So to get from 3 up to 7, I must take 4 steps up. This length right here is 4. And the same thing on the x's. This is a -1, this is a 2. To get from -1 to 2, you've gone a distance of 3. It's easy enough to calculate the length of these 2 sides, a vertical line and a horizontal line. It turns out that's everything you need to figure out this side. Because there's this theorem called the Pythagorean theorem, which says that anytime you have a right triangle, the sum of the squares of the lengths of the legs, a lot of ofs in there, is equal to the square of the length of the hypotenuse. What I'm saying is if we call x our answer, Pythagorean's theorem tells us that 4 squared plus 3 squared has got to be equal to x squared. And since I know 4 squared is 16 and 3 squared is 9, what I get is that 25 is equal to x squared. So if I take the square root of both sides of the equation, I get x equals, really I get plus or minus 5, but since we're talking about distance, I know it's the positive number and I get the same answer. These might look completely different, but they're really not. Y2 minus y1, this first term here, is just saying find the length of this vertical line. This 4 right here just came from subtracting the 2 y's. And similarly, this -3 came from subtracting the 2 x's. Yeah, I wrote 3 here and it's -3 here, but that doesn't matter because we end up squaring it in the next step And when you square a negative, it turns positive. So you could do this formulaically, but really this is the exact same. The difference is this distance formula, instead of solving for distance squared, instead of saying this is a squared, let's try that again, plus b squared equals c squared, it says, well, you don't want c squared. You don't want to know what x squared is. You want to know what x is. So instead of leaving this as a squared plus b squared equals c squared, it takes the square root of both sides of the equation to get rid of the squared on c squared. This distance formula is really just c equals the square root of a squared plus b squared. Or we're talking about a squared and b squared, or a and b. I think that's enough on that. So yeah, do it however you want. I don't care which way you do it. Formula is probably a little bit easier, but you're probably less likely to remember that, on a final or something. So maybe draw a picture if that helps. I think that's everything I want to talk about on quiz 7. So now let me go through some quiz 8 topics. The general idea in quiz 8 is we're talking about lines. We kind of hit on some of their key topics already above in quiz 7, but I'll do a little bit more on those down here. Really what we want to know is 2 different forms. And there's a few in there. The first one, point-slope form. Point-slope form tells you that y minus y1 equals m times x minus x1 is the point-slope form of a line with slope m that passes through x1, y1. So what I'm saying is if you're in the case where you're told the slope and one point that the line passes through, you can take this formula and plug in all the pieces. This is generally not considered the standard form of a line. The standard form of a line is this thing which we refer to as slope-intercept form. Slope-intercept form looks like this, y equals mx plus b. This is a line with slope m and y-intercept b. What you will be asked to do is you'll be given a question where you're not told the y-intercept, you're not told what b is. So like in this specific problem, it tells me that it doesn't give me the y-intercept. It gives me enough information to figure out the slope, and it gives me a point. So this problem is better suited towards this method up here in red. But once we get it into this form in red, we can do some algebra to write it in this form in blue. So what I'm saying is, in part A, it says use point-slope form, that's this first one, to write an equation for the line that passes through these 2 points. So what I need for point-slope form is 1 point, cool, I got 2 of them, got more than enough, and the slope. Slope, as we saw above, is the difference in the y-coordinates over the difference in the x-coordinates. Rise over run, maybe you heard in another class. So if I arbitrarily name them x1, y1, it's not a 1, x1, y1, and x2, y2. You can name them whatever you want. Then I can figure out the slope. See, y2 is, looks like -5, y1 is 3, x2 is 4, and x1 is 2. -5 minus 3 is -8. 4 minus 2 is 2. So what I get is a slope of -4. Now that I know the slope, I can take either of these 2 points, maybe I'll use the one that I called x1, y1 so it'll match up with this formula better, and plug in all the pieces. Y minus, y1 is 3, equals m, -4, times x minus 2. This right here is an equation. It's an equal sign, it's got x's and y's in it. And specifically, it's an equation of the line that fits these given criteria. This right here would be your answer. Typically, when we talk about a line, we don't write it in this form. This is not what's referred to as standard form. Standard form is slope-intercept form. But you're like, I don't know the intercept. It didn't give me the intercept in this problem. That's okay. What I can do is I can take this point-slope form and solve it, move the pieces around algebraically so that it looks like this. What I'm saying is get the y all by itself, add 3 to both sides. But there's no parentheses in here, so I should get rid of these parentheses also. To get rid of the parentheses, I'll take the -4 and distribute it through. So what I'm saying is maybe let's first take -4 and distribute it into the parentheses. Negative 4 times x is negative 4x. Negative 4 times negative 2 is positive 8. Common mistake is only distributing a 4, not a negative 4. It's the negative 4 you have to distribute through. This isn't y equals mx plus b form yet, but if I add 3 to both sides, I get negative 4x plus 11. This is y equals mx plus b form. Specifically, this is the standard form of a line whose slope is equal to negative 4 and whose y-intercept is equal to 11. If you were handed this, it would be easy enough to graph this line. So what we did is we took some information, kind of imperfect information, turned it into an equation, then fiddled with that equation a little bit so that we could get it into a prettier form. Point-slope form, slope-intercept form. Parallel and perpendicular, we kind of talked about these a little bit already. Find the slope-intercept form. Okay, so slope-intercept, you're thinking y equals mx plus b, of a line parallel to the above. Okay, so the line above had a slope of negative 4. If we're parallel to that, we must have the exact same slope. Our m must be equal to negative 4. However, this time, instead of passing through these points, it only gives us one point that it passes through, 4, 9. So we'll have to use this as x1 and this is y1. Note that we don't know the y-intercept. Since we don't know the y-intercept, we can't jump straight to slope-intercept form. But what we could do is use point-slope form, say y minus y1 equals m times x minus x1, and solve it so that's in slope-intercept form. Y minus 9 equals negative 4x plus 16. Y equals negative 4x plus 25. What I now have is the standard form of a line, the slope-intercept form of a line, of the line described here. A little bit tricky because they don't tell you the slope, they tell you it's parallel to something else. But since we know the slope of something else, we can figure out the slope here. One extra little twist they could throw in there is instead of saying it's parallel to something else, they could say it's perpendicular to that something else. If you remember from our discussion way up here, in order for two lines to be parallel, to be perpendicular, their slopes must be negative reciprocals of each other. What I mean by that is the reciprocal of negative 4 is 1 divided by negative 4, but the negative of that would be positive 1 over 4. The negative reciprocal of negative 4 is positive 1/4. These two things are negative reciprocals of each other. Now that I know the slope, I can do the exact same method. Gave me a point. I want slope-intercept form? Sure. Y minus y1 equals m times x minus x1. But that's not the answer it wants. This is point-slope form. It wants slope-intercept form. So go through those same steps to make it look like y equals mx plus b. Distribute the 1/4. Add 9 to both sides. You got your answer. The tricks here, I don't know. I mean, I guess it didn't give you the slope. That makes it a little bit harder. I was debating whether I should show you. I'm going to show you another way to do these problems. Any of these problems that I've been using point-slope form to get to slope-intercept form, there's actually a way to jump straight to slope-intercept form. So what you learned above is useful. It's a good way to do this stuff. It's especially useful if it asks specifically for point-slope form. But if it just asks for slope-intercept form, so like if I started out down here, and I really hated this y minus y1 nonsense, what I could do is I could jump straight to the final answer. I could be like, I want my answer to say y equals mx plus b. The problem is I don't know m and I don't know b. Well, that's not entirely correct. I do know m. I know that m is equal to negative 4. It's really just b that I need to know. If I could somehow figure out b, the answer is going to be 25. But if I could figure out b without doing all this, I wouldn't need to do all this. The way you can figure out b is, since it goes through this point, when x equals 4, y has to equal 9. So I can plug in 4 everywhere I see an x and 9 everywhere I see a y, and what that would give me is an equation with only one unknown in it. There's no reason I can't solve this equation for b. Right? 9 equals negative 16 plus b. So if I add 16 to both sides of the equation, I get b is equal to 25. This is not my answer. The answer is this thing that's boxed here. But now, since I already knew M and I know B, I could jump straight to this answer. Two ways to do the same problem. I think your book will teach you this way. Just figured I'd mention it. Now you know one more way to do these things. Moving on, intercepts. We talked about intercepts already, x and y intercepts when we talked about a circle up here. It was pretty hard when we talked about a circle. We can also find the x and y intercepts of a line. This specific line, I could graph it. You don't need to graph it. This is some line. What does it look like? Pretend you don't know. Maybe it's this line. I don't know what the hell it looks like, but it's going to cross the x-axis somewhere and it's going to cross the y-axis somewhere. And what this question is asking you to do is figure out the x-intercept. Figure out what the x-coordinate is here. Figure out the y-intercept up here. Figure those out, you got your answer. The nice thing is we don't need to draw a picture to figure out that answer. And since that picture wasn't the right picture, it's a good thing. One more point I want to make that just occurred to me before I go on. I don't know how picky the homework's going to be. What I figured out here for example, I said these are the x-intercepts. These are the x-coordinates of the x-intercept. This point right here is a point, so it's a coordinate pair. It's 1/2 minus the square root of 21 over 3. That's its x-coordinate. Its y-coordinate is 0. Similarly, this point up here, its x-coordinate is 0, and its y-coordinate is negative 2/3 plus the square root of 91 over 6. On a test, I'm perfectly fine with you just giving me the x-coordinate of the x-intercept because it's kind of obvious the y-coordinate's always 0. But I'm a little bit scared that the computer will be picky, so I wanted to make that little note there, that if it's an x-coordinate, tell it that the y is 0. If it's a y-intercept, tell it that the x-coordinate is 0. Okay, so moving on down here, find the x and y intercepts of this line. Well, if you remember for x-intercept, all we did was we made y 0. 2x minus 3 times 0 plus 6 equals 0. Sure, I can solve this for x. 3 times 0 is just 0. So I got 2x plus 6 equals 0. 2x equals negative 6. X equals negative 3. This is the x-coordinate of the x-intercept. I'm fine with you giving me this as the answer, but maybe a more precise answer would be something like this. Y-intercept, same idea. As we saw above, for the y-intercept, we figure it out by making x equal to 0. Take this equation, plug in a 0 everywhere you see the letter x, and solve. 2 times 0 is 0, so I get negative 3y plus 6 equals 0, or negative 3y equals negative 6, and thus y equals positive 2. Divide both sides by negative 3, which is fine if I'm grading these. If you're scared about the computer marking it wrong, put it in like this. X and y intercepts of a line. Same idea as how we did them for a circle. If I confused you above, look at this for a little while first before you look at the x and y intercepts of a circle, because it's very similar. It's just the standard form of a circle is more complicated algebraically, so when we start solving, it's harder to do. Okay, last couple problems. Function families. I don't know. This is vocabulary your book uses, so I guess I should be on board with it. It's saying that there's lots of different functions out there, which it starts to introduce in quiz 8. And it kind of tries to make families, different types of them. It breaks it up into 4 different types. So a function that would fit this root family is one where you see a square root sign, or a cubed root sign, or a fifth root sign. For example, 3 times the square root of 2 minus x plus 11. This would fit this root family. Why? Because I made this square root sign right here. Another example, I don't know, the cubed root of 2x. Sure, there's a root in there. It's a function. Looks like a root function. Polynomial. Polynomials look a little bit different. They're sums of terms. And each term is just a number times x raised up to some power. And that power has to be a positive, a non-negative integer. Here's an example of a polynomial. I'm adding together a bunch of things. Each of those things, called terms, have a coefficient, the number in front of the x, and then x raised up to some power. Wait, I don't see a power right here. Right, that's because x is just x to the 1 power. There's an implied 1 here. What about our constant term over here? There's no x's here at all. Well, either you could think about it as there's x to the 0 power that we don't even have to write because x to the 0 power is equal to 1. Or you could just say, yeah, polynomials, they're allowed to have constant terms too. They're allowed to have numbers added to them at the end. Another example, 3x to the 7th power minus 11. Sure, this just has two terms, coefficient x to the 7th and my constant term. Those are two polynomials. Linear functions are a subset of polynomials. So linear functions, like we dealt with above, if they're written in y equals mx plus b form, 3x plus 2, or g of x equals 1/2 x minus 5. These are linear functions. Note, these are both polynomials. The only difference is they're a specific type of polynomials. They're polynomials where the terms all either have x raised up to the first power or they're just a constant term. So these are not linear functions, they're polynomials. These are both polynomials and linear functions. Finally, rational functions. Rational, think fractions. A rational number is a number that you can express as a fraction. Rational functions are something divided by something. 3x plus 2 over x plus 5, sure, that's a rational function. 17x divided by x to the 9th plus x to the 7th plus 5, sure, that's a rational function. Fractions, rational functions. I think on the quiz these are true, false. They give you something and they say, true or false, this is a polynomial function. Or they say, multiple choice. Here's a function. Is it root, polynomial, or rational? So it's not like you need to come up with examples, but here are a couple of examples so that you can do those quiz problems. Finally, a little bit of vocabulary on functions, then I can finally end up this. A function, there's a lot of different ways you can write functions. This form I used above is more standard. But you can also write it as a relation, as a bunch of different pairs. And so what we're saying here is we have this relationship that 1 is related to this 1, this 3 is related to this 5, this 4 is related to this 2, and this 6 is related to this 5. And the order is very important. It's like 1 goes to 1, 3 is going to 5, 4 is going to 2, that's not a 2, 2, and 6 is going to 5. Not all relations are functions. Only a subset of relations are functions. This one in particular is a function. The test to figure out whether it's a function or not, maybe I'll tell you what's not a function. It's not a function if one x value goes to more than one y values. Values. So in this case, my x's are 1, 3, 4, and 6. And they each go to different places. Consider a different relationship. What if I had 1 go to 1, 2 go to 1, 3 go to 2, and 4 go to 10? Is this a function? Turns out the answer is yes. It's perfectly fine for two different x's to go to the same y. What is not okay is if I have 1 go to 2, 2 go to 5, 3 go to 7, and then 2 go to 9. Note that 2 is going to both 5 and 9. That's what's not allowed. This is a function. This is not a function. This one does not pass that test. So the one that was given was definitely a function, but just saying yes might not be enough to explain what is and what's not. Maybe with these two examples, then you get the hang of it. Domain of a function. The domain is just all the different x's. It's all the different leading numbers in the pair. So in this case, it's the number 1, the number 3, the number 4, and the number 6. In this case, it's the numbers 1, 2, 3, and 4. In this case, it's the numbers 1, 2, and 3. You don't have to repeat 2. It's 1, 2, and 3, just those numbers. What about the range? Range is all the y's. So the y's I have 1, 5, 2. I already said 5. Usually you write them ascendingly. Say the range is 1, 2, 5. 1, 2, 5. The range here would be 1, 2, 10. The range here would be 2, 5, 7, 9. Domain is all the x's, range is all the y's. It's a relation if every value in the domain goes to, if every value in the range it's hard to explain what a function is. It's not a function if one value in the domain goes to more than one value in the range, like we saw here. Maybe I'll call that good. I think I'll end the video here. Let me know if you have any other questions.